Last episode, we got events out of a service reliably, at least once, which means duplicates are guaranteed. Now we're on the receiving end, and it has a hard job. Those events arrive maybe more than once, maybe out of order, definitely, while things occasionally fail. If your consumer isn't careful, a duplicate event double counts or corrupts your data. The goal is a consumer that's idempotent. Processing the same event twice does exactly what processing it once does, and that builds a local view it can answer from, all on its own. Let's build it. First, accept the reality. Events arrive at least once, which is a polite way of saying the same event will, eventually, be delivered to you more than once. A network blip, a redelivery after a slow acknowledgement. It happens constantly at scale. Now imagine your handler naively adds a member to a team every time it sees a member-invited event. A duplicate, and that member is on the team twice. Double counted, corrupted. The property you need is idempotency. Handling the same event twice must have exactly the same effect as handling it once. Not usually, always. The fix mirrors the outbox. On the receiving side, an inbox. The inbox is simply a record of which message IDs this consumer has already processed. So the handler's first move, before it changes anything, is to check the inbox. Have I seen this ID before? If yes, it just skips it. The work is already done. If no, it processes the event and records the ID in the same transaction. And here's where last episode pays off, because the producer gave every event a deterministic ID, derived from the business fact, not a random GUID. That ID is exactly the deduplication key. Two copies of the same invitation carry the same ID, so the second one is recognized and dropped. In Trellis, the consumer wires up three things. First, the inbox itself, keyed by a consumer ID, and that ID must stay stable across deploys because it's part of the dedup key. Rename it, and you'd reprocess everything. Second, you register your handler for the integration event, the code that projects it into your read model. And third, the pump, a hosted service that receives messages from Service Bus and hands them to the inbox dispatcher, which dedups before your handler ever runs. Your handler gets to assume it's seeing each event exactly once. Here's the consumer side, end-to-end. Service Bus delivers the event, possibly more than once. It hits the inbox, which checks the ID and drops any duplicate. Only genuinely new events reach your handler, which runs once and projects the event into a local read model, a table shaped for exactly the queries this service needs to answer. And that red model is the payoff. When projects needs a member's name or role, it reads its own copy. It never calls the member's service. The data was pushed to it, ahead of time, by events. Let's dwell on why the read model matters so much, because it's the whole point of doing events this way. The read model is a local copy, shaped for exactly the queries this service answers, fast and entirely under your control. And the rule that falls out of it is the one to remember from this whole series. Answer from your own store. When your service needs data another service owns, you don't make a synchronous call to fetch it on demand. That couples your uptime to theirs. Instead, you already have a local projection, kept current by events. So if the producer is completely down, your service keeps right on serving reads. You've traded strict, instant consistency for something often more valuable in a distributed system, independence. Eventually consistent, but never coupled. So that completes the eventing picture. Producers write events to an outbox and relay them at least once. Consumers dedupe those events in an inbox using the deterministic ID, handle each one exactly once, and project it into a local read model they can answer from, without ever calling back. Idempotent in, independent out. That's how services stay decoupled and resilient while still sharing what they know. We've now built the whole distributed system, identity, authorization, and eventing. Next time, the finale. We run all of it locally, wired together, with one command, using Aspire. Subscribe, and I'll see you there.